A pendulum with a chord length of r equals 1 meter swings in a vertical plane. When the pendulum is in the 2 horizontal position, theta equals 90 degrees and theta equals 270 degrees, its speed is 5 meters per second. A. Find the magnitude of the radical acceleration and tangential acceleration for these positions. B. Draw vector diagrams to determine the direction of the total acceleration for these 2 points. Calculate the magnitude and direction of the total acceleration.
Hello kiddies. So for chapter 4, problem 53, at the top I just copied the diagram straight out of the book. And the givens are that the radius equals 1.00 meters, and at theta equals 90 degrees and theta equals 270 degrees, the speed is approximately 5.00 meters per second of the pendulum. We will start with part A. In part A, what you are required to find is the magnitude of AC and AT at 90 degrees and 270 degrees. And then to find that, use the equation AC equals V squared over R, and we were actually given the speed in the givens as seen above as 5.00 meters per second, and then you would square that and then divide that by the radius, which was also given as 1.00 meters, to get a centripetal acceleration of 25.0 meters per second squared. And now to find AT, the tangential acceleration, that just equals gravity, or 9.80 meters per second squared. Okay, so for part B, what we are basically doing is drawing vector diagrams to determine the direction of the total acceleration for 90 degrees and 270 degrees. So basically what you do is you start out by drawing the circle, and then you draw your vectors. So first you have the vector going down of 9.80, which is the tangential acceleration, which we actually found above. And then that 25.0 value is the centripetal acceleration value, which we also found in part A as 25.0 meters per second squared. So you have those. And then you draw the theta marks, and then that's where theta goes. And in theory, these two boxes should be the same size. And then your A is actually the direction of the total acceleration. However, you do not have theta. But that will be where it is once you find theta. And that's your answer. So actually many times in physics like this one, all three problems, parts of the problem, part A, part B, and part C, all kind of interconnect. And so for part C, what we are going to do is find the magnitude and the direction of the total acceleration. So the direction of the total acceleration is actually what you drew the vector diagram for in part B, which is that theta. And so what to do to find the magnitude is you use the equation A equals the square root of AC squared plus AT squared. And AC and AT were both found in part A, as seen there, 25.0 meters per second squared and 9.80 meters per second squared. And you go back and you plug them basically into the equation, and then you multiply and take the square root, and you get the answer of the magnitude of acceleration equaling 26.8 meters per second squared. And so now you have to find the direction of the total acceleration, as seen by the theta marked there. So now to find that is you take the inverse tangent of AT over AC. And so you basically plug in those numbers, 9.80 meters per second squared over 25.0 meters per second squared, divide that, and then take the inverse tangent of that decimal place, and you get 21.4 degrees, which is seen here as your total acceleration, or the direction of the total acceleration. And that is what you do for part C.